Okay, good afternoon. This is Scott Dahman of PowerWorld Corporation, and I'm pleased to have with me Professor Tom Overbye of Texas A&M University and also of PowerWorld Corporation. He is currently a professor and holder of the O'Donnell Foundation Chair 3 at Texas A&M. He's also been instrumental in developing the Smart Grid Center at Texas A&M, where they do a lot of research and educational outreach. He received all of his degrees in electrical engineering from bachelor's up through PhD from the University of Wisconsin at Madison. He was previously a professor of electrical and computer engineering at the University of Illinois at Urbana-Champaign, and there is a causal relationship between that fact and the fact that we are headquartered as PowerWorld Corporation in Champaign, Illinois. He's the original developer of PowerWorld Simulator, the kind of the original code that became the commercial software tool. But of course, we've got a huge team of developers right now working on PowerWorld Simulator. He's an author of a widely used power system analysis and design book, and is also recipient of the IEEE Power and Engineering Society Outstanding Power Engineer Educator Award, an IEEE Fellow, and a member of the U.S. National Academy of Engineering. So take it away, Tom.
Okay, thanks, Scott. Today I'm going to talk to you mostly about a new feature that we've added to PowerWorld in version 24 called regions. I'll also talk a little bit about a related data structure, which is routes. So let me just get going here. So the idea is regions are just a way of showing power system info or grouping power system information geographically. So a region, you can think of it as a state boundary or a county or something like that. It just is defined. It's defined geographically. It has a latitude and longitude, set of latitude and longitudes for its boundaries. Regions consist of one or more simple polygons, and a simple polygon is just one that does not intersect itself. That is to say, it's not like a bow tie, and it doesn't have any holes in it. It doesn't have to be convex. It can be kind of as complicated as you want, but you just have to make sure it does not intersect itself or have any holes. A region is composed of a set of these simple polygons. We call each one of these polygons a subgroup. And the reason why we did this is this allows you to model regions that have different components. For example, islands associated with them. And then the idea of regions is that you can use them to easily summarize power system information. And then I'm going to show you that you can also use them to visualize power system information. And I should say regions can be stored in a PWB file, but you can also load them from an aux file. We'll get into the details in just a second. The whole idea in developing this was to make it simple, or as simple as possible, and we think is actually pretty simple, for people to figure out what is located in different geographic locations. And then once you've done that, you can use these regions on different cases because a region is power system independent. Just like a state boundary doesn't depend on what's in the state or what power system components are in the state. Once you've defined that boundary, what's in that boundary is what's in that boundary. Regions do, of course, though, require that your power system information have latitude and longitude values associated with it. Otherwise, we can't put them in the location. So I want to emphasize that these are power system independent and can be easily shared between cases. The other thing I want to emphasize is we're going to be showing regions graphically, but regions in and of themselves are not display objects. They're kind of a power system object. You can think of them as sort of being related to power system zones. You can visualize a zone, but the zone itself is a component. Okay, Before I go on, I did want to add a nifty new feature that has just recently been added to PowerWorld. And some of the motivation for adding this feature was as we started, we store a lot of information in a PWB file, and we added more information to PWB file because we just added regions, and we were trying to figure out a way to make it easier for people to see what was actually in a PWB file. So what we've done is on the case information tab of the ribbon, we've added a new dialog. It's called the case memory usage dialog. And this dialog shows you the memory that is being used in a PWB file by the different power system application. So I've got an example shown there. This is actually one of the cases that I'm going to use in explaining regions. The total file size is about 2.69 megabytes. It's got a little bit of power system stuff. It's got a little bit of contingency analysis stuff. Because this was an example that I was using to show regions, I've got a lot of region information here. And let me um, I've got, this is the total size of the file. This is what's contained in the power system model. This is what's shown with transient stability. This is what's shown with regions. So we wanted to let people see what was being used by the different power system applications in the PWB file, and then make it easy for you to delete what is not needed. And this is kind of get rid of what we call case bloat, where you can just have a PWB that seems too big to be true, and it's because you've got extra information stored in it. This is an example that I will show in just a couple seconds to illustrate regions. And I did not even realize that I had transient stability data in this case, and I really didn't want transient stability data in this case. It actually has contingency analysis data, and I don't want that as well. So if I wanted to, I would just go down and I'd check delete transient stability results. If I wanted to get rid of the I guess that's all I'd get rid of here. Maybe some optimal power flow results. I'd check that. And then I can just click this cleanup case memory, and it will delete that memory next time. It doesn't delete the usage in the actual case. It just, well, it deletes it in the case, but then it's reflected in the PWB the next time that you store it. But I think you'll find this a pretty useful feature. And that's available. I think it's in a pretty recent patch, but you'll have it very soon if you don't have it already. Little bit on regions. Regions are defined geographically. So I did want to say a couple words on geographic coordinate systems. Latitude and longitude values can be expressed either in degrees, minutes, seconds, what we call DMS, or they can be expressed in decimal degrees. You can say the latitude is 40 degrees north, 0 minutes, 0 seconds. So you can say it's 40.0 degrees north. PowerWorld mostly uses decimal degrees. The distance per degree from a latitude point of view doesn't change with latitude, or yeah, the distance per degree latitude is constant. It's 111.1 kilometers or 111.1 meters per thousandth of degree. The distance per degree longitude varies with the latitude. Um, the point I want to make here is as long as the desired accuracy isn't too high, then the latitude and longitude values can be thought of as globally unique. And this will mostly be the case in PowerWorld Simulator. But one thing that we ran into with developing regions is the issue that latitude and longitude, as you get more accuracy, actually are not unique. And the reason for this is the Earth is not a perfect sphere. It's flattened a little bit. And the continents themselves are not fixed, but rather they're moving. For example, North America and Europe are diverging at about an inch per year. And you might say an inch per year, who cares about an inch per year? And from a power system point of view, we really don't. But if you're doing something with geographic data, say parcel boundaries, your lot and your neighbor's lot, if that boundary point we're moving an inch per year, pretty soon your fence is going to be on the other person's property or vice versa. So that can be an issue. So to address this, when you really want to get high precision, you have to introduce the concept of a geodetic datum or a reference frame. And we run into these when we're reading in region information, and there are actually hundreds or maybe there's thousands of different geodetic datums. Um, PowerWorld doesn't support most of them. Luckily, there are some common global ones, and the most popular one is what's known as WGS84. That's what's used with the GPS systems. So this is what Simulator mostly uses when it's importing, and it always uses when it's exporting geographic data. I just wanted to bring this up because sometimes if you start loading in some geographic data to use with regions, PowerWorld might not support it. It might not support it because it might be on a reference frame that we don't support. The solution to that would be to use some other GIS package and convert it into something like GIS 84. I don't think this will be an issue for most of the data that you'll be dealing with power systems, but in testing regions, we certainly did run into it. For example, I was testing the regions and loading parcel data for a county, and it was on a local coordinate system that we didn't support. Okay, the examples I'm going to use here fall into two main categories. One is a 37 bus power system that covers the Hawaiian island of Oahu, just an example system. It's a synthetic grid. Actually, both are synthetic grids. It's just useful for explaining regions in a small case way. It will be a case that can be used by the free 42 bus educational version of PowerWorld. And then the other one is much larger. It's an 82,000 bus synthetic grid that covers the lower 48 states of the US and DC, what we call CONUS. And it will demonstrate being able to use regions on very large cases. All the files used in this presentation are available at the website given there. Okay, so this is the 37 bus case, covers the island of Oahu, which is in Hawaii. It's where Honolulu is at. And in the right slide, I've got the case with no regions in it. And in the left image, I've got the case where I just kind of hand drew three different geographic regions. I labeled one region north, I labeled one region west, and one region east. They're very simple regions, just a couple boundary points each. Maybe I, for whatever reason, wanted to have a grouping of this case geographically. Okay. This is the other one. It's an 82,000 bus case. The image on the left shows the one line with the different colors showing the different voltage levels. And then on the right, what we're going to use for this case is to visualize results using about 3,000 US counties or equivalents. And then I'm going to show you how you can take power system data and actually make some nice visualizations with it as well. For example, the image on the right, if I wanted to take this case and visualize the current wind power output by county and then color it by its value, that's what it's showing. This image here is also for that 82,000 bus case showing the CONUS counties. And here I'm coloring the counties based upon the predominant generator fuel type in each one of the locations. What I hope to show you today is it's actually very simple now to create these displays in PowerWorld and to group the data. It'll be relatively simple to do. Okay, so regions can be shown either using the regions dialog or using one-line diagrams. The region dialog is just available from the tools. We put it in the, let's see, I guess I can show it here. In the tools, it's under weather. And then if you go down, you can see routes there, which we'll talk a little bit about at the end, but there's regions. If you click on regions, it's going to bring up a dialog that has all the regions in your case. This is one of the cases that I don't have any regions set up for yet. If I opened up the Conus 82K bus case, and went to regions, now I'm going to see a lot of regions. In this case, I set up regions that had the state boundaries, and then I also set up regions that had the counties. So I've got about 3,100 different regions in here. And what we'll see later on is for each one of these regions, I can show you specific power system information about that region. And this is kind of made this a little bit too, for example, this is saying how much generation is in each one of the US counties. And it's just a regular case information display. So this is saying, hey, Texas has the most generation here, followed by Florida and California. So yeah, I'll get to that in just a second. Alrighty, so that's the way to see the overall regions display. For each one of the regions, just like on a regular case information display, if you take advantage of the right-click menu, you'll get the first option will be the region information dialog, and that shows you information about a particular region. So in this case, I'm looking at that Oahu one where I had the north region defined. This lists all of the different buses in the region. And let me go ahead and open that case here. So if I go to regions, right click on a particular region, and this is the north one, and do show dialog, it shows me a dialog that gives me information about what buses are in that region, what generators are in it, what loads are in it, branches in it, tie branches between the regions. If I want the boundary points, there are the boundary points. The key on this is that these objects are not assigned to a region. They are in a region based on their geography. Okay, so you don't have to assign them, and that makes it case independent. Okay. When we started developing regions, we had to figure out how do we name these things. And we started out with just one name, and that didn't last for very long because if I say the name Champaign, it's like, well, what am I talking about? Maybe I'm talking about Champaign County. So if I say Champaign, maybe I want to have a class name, and the class name is kind of a way to group things. In the previous example, I had a class name of states, I had a class name of US counties. But it doesn't take too long to realize that just one name is not going to make something unique. So we ended up actually using three names to make something unique. It might be Champaign, it would be a US county, Champaign, Illinois. There, that one is unique with two names. As we were doing this, though, we realized that actually, even with US counties, some counties require three names to make them unique because it turns out in the US, there are some states that have independent cities, like St. Louis in Missouri. There's a St. Louis County, and then there's a St. Louis Missouri that is also in a county record, but it's referring to the state. So we realized we really needed three names to make things unique. So names are a class name, and then there are up to three proper names. The way we distinguish this is we put a $sign between the different parts of the name. So the region's full name is going to be its class name, $sign proper name one, $sign proper name two, $sign proper name three. All of these class name proper one, proper two, proper three are optional. So for example, if you just wanted to use a class name in proper one and proper three, it would look like this here with two $signs next to each other. Usually when you look at these, you're going to be looking at the class and the three proper names separately, so you don't have to look at the full name. But the way that we make them unique is based on their full name. Okay, so on the dialog for a particular region, we've shown the full name up here, and you can do finds on that. Then we've got the class name, name one, name two, name three. And note the $sign is shown in there to differentiate them. Okay, on the region information dialog, which shows the details for each region, we have a number of different pages. If you want to know the boundary points are available. There's some display fields that are talked about later. We've got a summary page that provides some summary fields such as total generation, how much the generation can be increased or decreased, reactive reserves, and then breaking the generation down by fuel type. We'll probably add some more fields here, but this is where we're at right now. Summary of the total number of loads, generators and shunts in each region, megawatt, megavar, little bit of the geography there. Okay, so the question is how do you get regions into a case? And there are 5 different ways that you can do it. What I have been showing you so far is I've saved them in the PWB file, and this will probably be the most common approach. You load the regions, you get a case and it's already got regions in them and they came from the PWB file. So in that case, in that sense, you don't have to pay much attention to them. Probably the second most common way to do them is you will load them from an aux file, and I'll show you how to take existing regions and store them in an aux file and load them up. The third way, which is how I got a lot of these initial regions that we've been testing with, is to load them from shape files. If you're familiar with Geographic Information System, GIS software, you're very familiar with shape files. Shape files are a file format that was developed by Esri. It's an open format, so it is widely used for transferring geographic information. I will say shape files are an old format with some parts of the shape file dating back more than 45 years, but they are still widely used. So if you're looking for new regions, you'll probably find what you're looking for as a shape file. You can manually draw the regions on a one line if desired. And then you can actually, as I will talk about, I guess I'll talk about in a second, is you can right click to insert a mostly temporary rectangular region. Okay, so how is a simple way to get started with regions? A simple way to get started with regions is if you have a one-line diagram, and I will close that up here. If I have a one-line diagram and I want to know what's in a particular area on this one-line diagram, if I go to a blank spot on the one-line diagram, right-click, there's a new option here in the right-click menu called View Temporary Rectangular Region. You select that, and then you click and hold down the left button and define a rectangular region. when you release the button, it's going to create a region that shows you what's on that part of the one line. And that is available on any one line, provided it is a geographic one line. It needs to have a geographic projection. And of course, your power system information has to have geographic coordinates associated with it. If those two conditions are met, you immediately get this. Now, we have a category of regions that we call a temporary region. This was set up to allow you to do this functionality. You just look at it, and presumably you don't want to keep this region. So when you close the dialog, if it's a temporary region, it's going to go away. If for whatever reason you felt like, wow, this is a great region, I want to save this, if you either uncheck this or you rename it, you set a new name here. You might say my region. And then click OK. It's going to save that region. So now you've got that region uh, saved, and you can use it however you would like going forward. But the idea is you're probably not going to be too concerned about having a bunch of rectangular regions in your case. But if you want, you can keep them. Okay, and this works in either the run mode or the edit mode. So I went through that. Okay, when we talk about regions, people often say, how do these relate to other groupings in the power system, like an area and a zone? The answer is regions are designed to complement the traditional object types. Of course, we still have areas, we still have zones, and they are useful. And objects are assigned to an area and they are assigned to a zone. So in that sense, you know, regions have objects, but they're not assigned to them. But just like an area and zone, they show lots of different fields. So if you right click and look at the display column option for an area or zone, you're going to have lots of different fields that you can show. These same fields are available with regions. The key difference is power system objects can only be assigned to a single area and a single zone. You have to assign them, and that makes the areas and zone power system dependent, and they need to be updated when things like bus numbers change. The advantage, of course, of areas and zones is they don't require geographic coordinates. A region, a power system object can be in any number of regions. So a bus might be in Champaign County, Illinois, but it's also in the state of Illinois. And if you had a region that maybe defined, the city of Champaign or something like that, it might be in that region as well. Any number that you want. Power system objects are in regions based on their geographic location. They are not assigned. This makes them the regions are independent of the case, so they can easily be used with other cases. Okay. Another way to easily add regions to a case is with shape files. As I was developing regions, I went out to various websites. Like one website I went to get the county data, and the state data is the U.S. Census Bureau. When you go out there, you will be able to download data in shapefile format. In developing the region functionality, we have greatly enhanced PowerWorld's ability to read in shapefiles. Now a lot of the complications that existed in the past have been taken care of. So this is an example where, say I want to import, we're using the Hawaiian island of Oahu as an example. Let's say I want to have some more detail about this. So I went out, I got a shape file that defined various districts in Oahu. So I gave it a class name, and then I go from the regions display, shapefile import, and I import regions from a shapefile. I just click that. That brings up our GIS shapefile data dialog, which has existed for a long time. and then I click on the read shapefile and I pick the shapefile that I want to load in, and a shapefile is given by the suffix .shp. You click the read shapefile, and then you will get on the shape list, it shows you all of the different data that is in a shapefile. Shapefiles can hold points and lines. Right now for regions, what we are using is we are importing a polygon, and this is where the concept of a simple polygon comes in. A polygon, though, as I mentioned earlier, might consist of one simple shape, but it actually might have many more parts. The subgroups that we talked about, since this is Hawaii, Hawaii, Oahu's an island, but it's got little islands associated with it. So in this third record, it's actually District 3, I believe, there's 10 subgroups associated with it. Okay, so you then have to pick what attribute do you want to use for the region name. Shapefiles come with an associated dbase file, and the dbase file gives you additional metadata associated with the shape. Here, the attributes I'm getting, which I select from the identify uh, tab there, I select the district number and I select the district name. And then I just click transfer shapes to regions and close. And it takes that data and it transfers it over to simulator and sets up regions. So here's an example of the shapefile data that I brought in for those 9 different Hawaiian Oahu districts. And this shows the number of boundary points, whereas the first example where I made my 3 regions up that had, 4, 5, 6 boundary points. Now, because we're doing much more detailed modeling of these districts, District 1 has about 5,700 boundary points associated with it, and it's got 9 different islands associated with it. How much detail you want depends upon the shapefiles that you load in. And with the example of the counties that I mentioned earlier, when you go to the Census Bureau website, you can get counties at different spatial resolution. So if you don't want a lot of points, you can actually get counties, or you can get shapefiles for counties that have a coarser boundary. Okay, so let me show you this. This is a visualization of the results, and I'll show you how to visualize it in just a second. But now I've got a much more detailed boundary for Oahu. You can see there's a bunch of little offshore islands here that are included in the shapefile, a bunch up there. That how much detail you get just depends upon the shapefile that you have. And if we go down to regions, now I've got these 9 different regions. And if I right click on either one, again, I get my dialog. I can see the buses in it, the generators, the loads, things like that. And there's now quite a few more boundary points associated with it. Again, how much resolution you need is kind of up to you. I will say we have set up PowerWorld so that it can pretty easily handle um, regions that in aggregate have 1,000,000 or 2 boundary points, which is what we're dealing with when we load up the U.S. counties, the CONUS counties, because Alaska in and of itself has a lot of boundary points. Okay. Deleting regions can be easily deleted. You can either delete all of them or you can delete a subset. For example, with the 82,000 bus case, I'm showing all of the CONUS counties. Maybe I don't want to see all the counties. Maybe I just want to see the Illinois counties. So what I do is I set up a filter that says, show me all of the counties that are not in Illinois. So I just say name two not equal to IL, and then I select delete all, and I delete all of them. And that changes the number of boundary points. I might go from 1 million for the the lower 48 plus DC down to 18,000 points. So how much you need is up to you. Okay, so as we developed regions, originally thought we just want to group buses and other power system objects by region, but then it became apparent pretty quickly that it's like we can't just have these really cool uh, data structures and not be able to show them to anybody. So, PowerWorld being PowerWorld with its visualization emphasis, we decided we needed to make display objects. So regions can be shown on one line using region display objects. So this is analogous to a bus being shown on a one line using a bus display object. The difference here, though, is that the shape of the region display object, the RDO, is not something that you can specify independently. It comes from the region, so you don't draw it in if you're using data that comes in from a shapefile. And then once you have a display, then you have to say, well, how do I set its attributes? The main attribute you're going to use is what's its fill color, but you might also be concerned about what's its border width and color. And then you start getting into other display issues like saying, well, what's its stack order? Should it be shown on top of the power system objects? Usually you're not going to do that. Usually it's going to be shown below them. So you have to pick where is it in the stack order. Okay. We tried to make this as automatic as possible, recognizing that a lot of people are going to insert data from shape files. When you insert a shape file, you can also automatically set up the shapes. There's an option when you're going to the shapefile import that says automatically add shapes to an open one line with a map projection, and it will, when you import stuff, add shapes to it. Okay, so when you start giving options for inserting shapes, you have to say, well, what format do I want for the shapes? So on the GIS shapefile data dialog, there's a tab here that says format. When you load a shapefile in, you can get options for or you get fields that let you say, is it going to be filled? And here I selected yes, and then what fill color do I want to use? So we were like, well, selecting all these fill colors, you don't want all your regions to be the same color, so you need them to be different. How do you make them all different? We added a little bit of a kind of some options where you can set the fill colors randomly out of a color palette. Here I set a light color palette, and it automatically sets the fill color, and it makes it easy to create the one line, which I just showed you. So this one line here was created using this sort of option. So it just took a couple clicks to go from a shape file to having this nice one line display. Okay. So there's an example. Once you have a one line display, of course, you want to be able to get access to the data. So when you have a one line display with these region display objects on it, if you right click on one of them in the background, you get an option for either the region information dialog for that particular region. This is district 2, I guess. Here's the data associated with it. Or if I want, I can go to the regions dialog and look at all the regions associated with the one line. And this sits in the background, so I can still right click like I normally do on the various power system objects. Okay. Okay, so we give you options for customizing their appearance. Okay, with regions, chances are you're going to want to use them on different cases. So we made it easy to save regions in an aux file. So if you go to the regions display, uh, you will see save in aux file. And if you click that, it's going to save it in an aux file. We actually decided to support two different formats for saving data in an aux file. You can either save the regions using what we call the fast subgroups in aux files, or you can save them using I guess the opposite of fast would be the slow uh, format in the aux file, the slow groups, subgroups in the aux file. The advantage of the fast groups and the fast subgroups approach is that you can quickly store millions of different boundary points. The disadvantage is it's not in as easily an editable format. So if you just want to deal with a few boundary points, we give you another option that lets you save it in a format that is a little bit easier to manually edit. Okay, so this is the uh, format where we save all of the subgroups on one line in an aux file. And as I mentioned, a subgroup, you can think of it as a part of a region. If the region just has one polygon in it, it's just going to have one subgroup. If it's got, 10 different islands, then it's going to have 10 different subgroups associated with it. The format is the name of the sub or the number of the subgroup, then the latitude, longitude for the first point, latitude, longitude for the second, and so on. And because some of these can have hundreds or thousands of points associated with them, it's not a particularly easy format to edit. But the advantage is because we just have to parse a single line to load that subgroup, it loads in really fast. The alternative format is to have it where each boundary point is a particular line in an aux file. This makes it very easy to edit. If you want to manually add points to it, you can easily do that, but it's going to load in a little bit slower. What we found is with regions, typical aux file load speed might be 300,000 data points per boundary points per second. So if you have a small case, then it's going to load fast. If you have a case that represents the U.S. counties, it's going to take several seconds to load. We were testing it with zip codes, and zip codes have about 25 million points associated with it, and that was taking a long time to load in. And we thought, well, who really wants to divide their power system by zip code? Maybe you do. Hopefully, you don't want to do it for all the zip codes in the U.S. because that is about 25 million boundary points, which is stretching it. Okay. Key takeaway to adding regions is a simple. Once you have an aux file, you just file load aux and it loads it up just fine. And that means once you've got the counties, if you want counties or whatever regions you want, once you got them defined, you can get them in any case you want. Just do file load auxiliary. And we've got a couple provided on the PowerWorld website already. If you don't have them, go get a shape file, provided it uses the common WGS underscore 1984 format, then we will be able to load it in directly. We load a couple other formats as well, but that are projections as well, but that's by far the most common one. Okay. In doing this, we thought, well, people might want to manually insert a region. And you can manually draw a region. So we gave you the ability to manually draw a region. I will show you that here. Uh, let's say I do open case Hawaii, no buses. This is editing, and in PowerWorld, editing a one line is done in the edit mode. So I have to go to the edit mode, and then I do uh, draw, and I select what I want to draw. Because regions are really aggregations, we put the regions under aggregations. So if you go down to aggregations, about halfway down, you see region. You draw a region just like you draw a line. So if I click on region, just like I'm drawing a line, I draw a region in, double click on it, and it gives me the dialog here, a new region, name it whatever you want. Click OK, and then you've got a region. Now I forgot to fill my region, so let me go ahead and fill it. So I'm going to right click on it like I'd right click on a line. Region information dialog. Under display values, I can set up the display parameters for the region. And when we were creating the region display objects, what we realized is that people would probably want to have display attributes associated with the region itself that could be used on display objects on different one lines. So we provided that option. But just like a regular one line object, you can have display attributes like that's just associated with the display object. So that would only apply to this one line. Let me use that here. I select the background fill. I change it, make it green here and click OK. And that's my region. Now in PowerWorld, we felt like once you enter a region, we have to be able to let you edit it. So just like a one line or just like a line, if you grab a vertex, you can move your region around and set it up however you want. Or you can actually, if you want to drag your region around, you could drag your region around. You're of course not going to do that usually, but it's available. If you don't want to make it so it can be moved around, if you go to the region dialogues, just like um, other objects, you can set it up to be immobile. And if it's immobile, then it's not going to move around. So, okay. So that's manually entering them. You can do it if you want. We think most people are probably going to load stuff in from shape files or aux files or have them in the case. Uh, you can add fields to show region values. And we use the generic model field right now for regions. You can add new one line or new RDOs to existing one line if you want. And I just went through how to do that. Okay, so I went through how to do this. Now, as we started developing regions, we thought, people aren't going to want to just show it in like a single background color. They would like their background color to be uh, dynamic based upon some power flow or power system attribute. So we set up the ability to use something called the region display style. A region display style allows you to customize the background color on your region objects based upon the an attribute that it's getting from the buses and other power system objects that are in that region. So this is an example where on my Hawaii one, I color the background color based upon how much generation is in each particular district here. And because regions are power system objects, you can also insert labels associated with these regions using the standard geographic data view option. So if you want to see things like the name of the region and whatever fields you want, That's just the same functionality that you use with any other geographic data view object. Okay, so this goes through some examples. This case here just applies it to a larger example, the Canis 82 bus case. Here I'm showing the wind generation, uh, same approach here on the dialogues that I went through. This display, and you have this on the link that I gave you, because I wanted to highlight the state borders. I actually have regions for the counties and I have regions for the states. And then I put the states at a lower display stack level. I put them at the base level, whereas I put the counties at the background level. And then I've got the counties filled and the states not filled. So that's how I'm getting the thicker lines for the states. It's all a single display. If you want to see proper names are strings, but you can also view them numerically. We put this in because maybe the data that you have for that proper name is naturally numeric. Like here's an example which for the counties and states, the Census Bureau assigns them a numeric code. So we added the ability to show it numerically. Um, Updating buses in the region, as much as possible, we try to automatically assign the buses to the regions. And usually this works fine, but there are ways that you can kind of change a region around or change what buses would go in that region that we can't automatically detect. So we give you an option on the region's dialog, to update the buses in the region. Why might the buses in a region change? The good news is usually they're not going to change, but you might change the region boundaries. If you go in and manually change the region boundaries, that's going to change what buses are in the region. You might insert or delete a bus. This is something that we tend to pick up automatically, so that's automatically handled. But you might actually go in and change the bus's geographic location, or since buses are often have their geographic locations derived from that of their substation, if you change the substation geographic location, that's going to change the bus's location, and that's going to change the whether it's in a particular region. We wanted to do this as automatically as possible, but we also recognize that on a larger case, it can take time to do this calculation, not very long, just a couple seconds. But if you make that automatic when somebody changes a substation geographic value, and we go through all the regions to see if it needs to be updated, that can get annoying very quickly. So let me show you this. I'll open up that Canis case here. And I go to the regions, and this is a pretty large case. It's got 82,000 buses in it, and I click update buses and regions. You can see it churning away here. It thinks for a couple seconds and then updates the buses in the region. This is a case that has, 1 million boundary points and 82,000 buses. So it's a fairly large scale case. So we think we've got this pretty fast, but you could certainly set up a region case that has 10 million boundary points. And if you're doing that on a case that has 82,000 buses, it might take a little bit of time to update things. Okay. This is one where I visualized it using a style where I set up the color of the style to be the generator fuel type in that county. And now you can visualize the counties in Canis and what's the predominant generator fuel type. And this is all dynamically linked. So when you do a powerful solution, this display would get updated just like any other display. This is a zoomed in view of the Pacific Northwest. Here I'm using GDVs to show, I think I'm showing the total generation in each one of the counties there, coloring it by the fuel type. So this shows an example of using GDVs with the regions. Moving regions to other cases, the styles are saved in the aux file. There's an option to save styles in the regions aux file. This means once you've defined a style, like the one I had to show the fuel types, I can use it on any case. So we were doing a project for Southwest Power Pool here at Texas A&M, where we were joining the US or the North American Eastern Western grids together. So we had a power flow case with 123,000 buses in it. Everything was geo-mapped on it, and we had the fuel types for all the generation. So I just took the aux file that I've been showing you here, and I loaded it up into that case, and I opened up the one line that I previously defined, and pretty much instantly I had this display here. So once you've got these things defined, they're available for any case that you want. And you might look at this one and there's nothing in Texas, and that's because this is a real grid example. And in this real grid example, we did not include ERCOT. So we just had the Eastern and Western grids. The case has Canadian Mexican buses in it, but I did not set up displays using Canadian or Mexican data. Certainly, there's a lot of data, shapefiles available on these or any other geographic regions. So if you want to do other locations, pretty easy to do. We recently added the ability to save regions in and other objects in shape files. This is pretty new. It was just added a couple days ago. So if you've got a June 4th or later patch, you have the ability to save regions into a shape file. And in saving the regions, we also let you save the fields, the power system fields associated with that. The caveat here is shape files date back to the database format that they use dates back to about 1980. And in that format, which is something that's not changing, the shapefile field names are limited to 10 characters. So when we take power system fields, our power flow fields, and need to put them into 10 characters, we had to do some special coding to make that work. So we make them unique, and then we actually export a CSV file so that you can see the actual names. The more common ones like gen megawatt, gen megavar, load megawatt, that's all going to fit in 10 characters. And as we were doing this, we realized that we can do this with every other case information display as well, as long as you've got geographic coordinates. So now on pretty much every case info display in PowerWorld, if you go to right click and look at geographic views, there's an option to save selected objects in a shapefile or save all objects in a shapefile. That will save the field data from your case info display into the shapefile format, with the caveat that the field names is truncated to 10 characters. So here's an example where I took this and I saved a bunch of data in a shapefile. These are the long field names that I had. Gen megawatt max natural gas. That's not going to fit in 10 characters. So we output a CSV file that is a mapping between what we named them, 10 characters, and their full name. So if you start using this, we might be able to do something else, but this is, we're stuck with the 10 characters, and in those 10 characters, you can't have any spaces. Okay, just recently we added combining fields or combining regions. If you want to take a couple regions and combine them, that is now straightforward to do. We are keeping the separate subgroups, but we do combine them. So here I gave an example where I combined regions 1 to 4 in my a Wahoo example. So if you need that, that's available. Um, on the routes, when we released version 24, we did add support for routes. A route is used to uh, give the it's sort of like a non-closed, it's not a polygon, it's not closed, so it's just telling you the geographic points that define object, say a transmission line, or it could be an interface going from one location to another, and you can put as many points in as you want. We have support for that, and you can start using it. And I think we'll be adding more functionality as people start using that in the future. A lot of other stuff that can be done with regions, but we did, realize we needed to get this out. So I think there's a lot of functionality available, and I hope people find it useful. So with that, if anybody's got any questions, I can answer any questions anybody has.
There is a series of questions in the chat, Tom, if you're able to read that from Zachary Zorns. I can also read them as well.
Why don't you go ahead and read them?
Okay. First one is, can regions be filtered using the area zone owner filter type display? I don't think that's in there yet. You can, it looks like you can do some advanced filtering based on regions, but you have any comments or things to add on that, Tom?
We haven't added that yet. I did think about that. Regions can be filtered using the, if I go in, and let me open up the Hawaii one.
Hey Tom, Zach here. While you're getting there, the thought was advanced filters, they get a little cumbersome when you want to, for example, filter multiple regions, and you have to add them one by one by one. Whereas the purple filter, it's easier to multi-select, and I like that functionality. So wanted to see if there was a better way than what I think there was, but it sounds like just the advanced for now.
Well, there's two aspects to the filtering. There's what you see, which regions you see, and that's just like, it's got quick filters and stuff like that. The other thing that I thought about, and if somebody wants this, we can easily add this, is I said buses are not assigned to regions. Buses are in the regions based upon their geographic location. But I was thinking, and somebody might want to just say, I don't want to see all the buses in the geographic regions. I want to see the buses that meet this bus filter. If that's what you're saying, we haven't coded that, but that would be relatively straightforward to code. It actually makes it easier, because when we're assigning buses to regions, what we would just say is you don't get assigned to that region unless you meet the geographic constraint and you also meet the bus filter constraint. Is that what you're thinking of?
I guess that's more on the implementation side.
Yeah,
Thinking more like
Tom,
show me Washington State, Idaho State, Montana State. That's the end user what I'm looking for.
Oh
Yeah,
yeah, to filter by states, you can just use a quick filter if yeah, that's pretty straightforward to do.
Yeah, states is straightforward, but like in Washington, all the counties east of the Cascades, now the quick filter gets a little kludgy.
East of the Cascades would be probably what you would want to do then is, did you say in Washington or?
Yeah.
Probably what you would want to do is just combine those counties and make up, which you can now do, and make up a region that is the counties east of the Cascade. Because
Yeah, region of regions, in
I'm
effect.
looking at it right here. There's like maybe, I don't know what, like 15, 20 counties east of the Cascades. you can combine those, and once you combine them and you make a count, you make a new region and you call it, east of the Cascades, then you've got that region defined, and you can use it in any case then.
Okay. Yeah, that's a fair approach. Thanks.
Our next question, Zachary's list was, can regions be scaled like injection groups, area, zone order? I assume what you mean there, Zachary, is that like you want to scale all of the load or something or all the generation that belongs in a region. Is that correct?
Correct. Yep.
So that'd be like a function that would have to be added to the scaling tool, I guess, the system scaling tool, if we wanted to make that available.
Correct.
Or you'd have to individually. I guess you could go through and individually select the buses, select the scale field to yes for all the buses that belong in that region from the region dialog or something like that. That it's a little bit like a multi-step process than I get.
Yeah. In my view, regions are very similar to injection groups, but there's, I guess, the geographic component. So injection group is an option in the scale tool. So if there's another tab that says region and then has very similar functionality, in my mind, that's how it would work.
And something that we haven't explored yet, but is probably pretty easy to do, is I can take you can't do it now, but you could say I want to take what's in this region and make it into an injection group. That doesn't exist now, but we could do it.
Tom, can you guys hear me? This is
Yeah.
Jamie.
Yes.
I think we just need to implement so that just like you can use advanced filters, you could use an area advanced filter on a bus. We need to make it so regions can be used across objects. I don't think that will be hard to add. Then
Yeah,
Zach
I will say, as we got into regions, I was like, there's like a list of stuff that is like, oh, I'd like to add this, I'd like to add that. And
yeah, exactly.
what we want is feedback that you're providing us to say what is the most important functionality that we've got. I think we've got a lot of important functionality, because as I've talked to people, they're like, yeah, I want to know what stuff is in this county or that. So we provide that, but then it's saying, okay, where do we want to go from that? And the most recent functionality we added, which actually meets your east of the Cascades, is to say I can combine those counties into a region, and I'll call it east of the Cascades, and then I've defined east of the Cascades. Or if you took a display and you just kind of drew on the map east of the Cascades, you could just draw that with a couple, I guess. It's how much precision do you want? Do you really care about whether some of the Oregon places get in there?
I'm an engineer, man, and I love maps, so I'm gonna go all in.
Yeah.
I get it.
I would take the counties and join them together then, if
Yeah.
east of the Cascades is defined by counties, and I don't know if it is, but if it is, then you can just combine the counties.
Yeah, to your point, there's easy way, a hard way, and you can do both in here.
Yeah.
Next question deals with whether region attributes can be plotted in transient stability plots. For example, the worst frequency in a region in a under frequency load shedding study. So I'm assuming what you mean by that, Zachary, is like you have a contingency, a transient contingency, and then you want to use the region as an aggregate for the frequency
exactly.
field, or some field like that. Like we can already do that, like with areas and zones, right? You can do the average frequency in the area or the max or min frequency in an area. So the same for region, I guess, is the request there.
Yeah, we do let you see the regions a bus is in, so that's available. But again, these are all things that probably can be done. I don't know if they can be done right now, but
Yeah, emphasis on the question was to be able to to plot make transient stability plot definitions with these things in them. I know, like, I don't think balancing authority has attributes that can be plotted right now. So I'm guessing regions would be in a similar boat, but end user talking here, that would be something I think that could be useful.
Yeah, you can't store stuff by regions right now.
Feels like in the short run, we need to add more fields to injection. Well, if you wanted the average bus frequency, though, injection group was limiting. But if we just made it easy to take a region and create an injection group out of it, then
A
we'd
region
get around
can
some of
show
this.
the average frequency in the region, just like we could show it in a zone.
Yeah, but we can't plot it, so.
I don't know how they can plot it.
It's okay for it doesn't exist now, and I've planted the idea, and you can think about it.
That's good. You're planning ideas.
I can certainly share these questions too with Tom and Jamie afterwards for further discussion.
Okay.
And there's a couple others in there too about, like, can region attributes be applied to bar charts or pie charts? And can regions be applied to contingencies? For example, if you draw a region perimeter of a fire, could you make a contingency that removes the elements that are in the fire?
Right now we don't have that, but again, the good future suggestions.
All right, appreciate it. Thank you.